On page 157, at the bottom of the page, we have some skills practice problems. And the first one just says to give an example of a point in quadrant 3. So let me go to my graph paper and get a picture of the quadrants. And I will show you one in quadrant 3. And you could pick any number of coordinates there. It's an infinite number that you could choose from. So they're just testing whether you know where quadrant 3 is. And I believe you do. If you've been following with me and understanding, you will know this. This is quadrant 1. This is quadrant 2. There's 3, and then this is quadrant 4. So they want us to pick a point, any point in this quadrant. I'm just going to pick one at random, just wherever my pencil falls in that quadrant. And the one that I chose by random choice is 1, 2, 3, 4, 5 back and 3 down. So -5, -3. The important thing about quadrant 3 is that both the x and the y are negative. All right, number 2. Which point or points lie on the line described by the equation y equals 3x plus 4? And they want us to test 4 different points. A is -1, 1. B is 0, -4. C is 1, 7. And D is 3, 13. So they want us to test all of those points. So letter A, let's look at that one. We have 3x plus 4. So the y coordinate is 1. The x is -1 plus 4. So we end up with -3, +4, 1 equals 1. So yes, this one is on the line. A is one of them. But remember, they said we could have more than one, so we need to test them all. B, we have 3x plus 4 there, so y is -4 and x is 0. -4 equals 0 plus 4. No, that does not equal 4. So this one is a no. Okay, so we have x equals 3x plus 4, same equation. And this time we have 7 equals 3 times 1 plus 4. So 7 equals 3 plus 4. That one is true. This is a yes. So this point is on the line. And then we have to check the last one, which is the same equation. 13 equals 3 times 3 plus 4. So 13 equals 9 plus 4. 13 equals 13. This is also a yes. So you have 3 correct answers for that particular question. Have to check them all to know which ones are true. Number 3. This one gives us a table of values and then a story. And I made my table too small, sorry. Should have 4 rows of x's and y's. So we have x first, then y, and we have 2 6, 4, 10, 6, and 14. All right. Lincoln says that the slope of the line described by the table is 1/2. So Lincoln is saying that the slope is 1/2. What error did Lincoln make? What is the correct slope? So I'm going to use 2 points on this table and calculate the slope for myself. Okay, so this is going to be x1, x2, y1, y2. So slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have 10 minus 6 over 4 minus 2. And we end up with 4 over 2 or 2 over 1 or 2. So I can tell you what Lincoln did. And here's the way I know. Lincoln's answer and my answer are inverse slopes, meaning that Lincoln's answer compared to my answer is upside down. So this is what Lincoln did. He said that slope is x sub 2 minus x sub 1 over y sub 2 minus y sub 1. Lincoln put run over rise. He had it upside down. And that means that his slope came out to be upside down. The correct slope is positive 2 or positive 2 over 1. Number 4. On the graph below, plot and label the point that represents the unit rate. So let me bring in a coordinate plane. I don't need the whole plane, I just need quadrant 1. So I'm going to use this one that allows me to make a bigger graph. Let's see if we can put it right here. And I'm going to sort of duplicate the graph in the book. I'm not going to do the whole thing because it's in the textbook. But let's go ahead and graph the first quadrant. And we have a point of 2, 4. So over 2, up 4. And they did label that for us. And then we have 4, 8. So over 4 and up to 8 is the other point. And then they have a graph that starts at 0, 0 and goes in the positive direction. So here's 0, 0. Now what that tells me is that on this graph I can find the slope, I can find the constant of proportionality, and I can find a unit rate because it passes the 0, 0 test. So let's calculate our slope using rise over run. You don't have to do the formula. You can if you want to. But we know that we rise 4 units and we run 2. We rise 4 and we run 2. So the slope using just rise over run is 4 over 2, or 2 over 1, or 2. So for my slope up here, I'm going to say that slope is 2. The constant for proportionality is 2, but the unit rate is 2 over 1. So that means we rise 2 and run 1. And we're supposed to plot that point. So this would be the point 1, 2. Because remember, x comes first. So over 1 up 2, right there is our unit rate. It is over 1 up 2. I like that one. That's a good question. Number 5. Let me duplicate before I read the story so you can follow what's going on there. Again, I'm not going to draw and graph out the whole plane. I'm just going to do what I have to make this work. We have a point at 2, 3. So over 2, up 3. And then we have a point at 4, 6. So here. And we have a line that is coming from origin up through there. Now, I can tell you, because there is the 0, 0 test that is met, we can find the slope, we can find the constant of proportionality, and we can find the unit rate. Okay. We also have a table to refer to in this picture, and it has 3 rows where the apples in pounds are the X value, and the the price in dollars is the Y value. And we have 1 to 170 and 3 to 510. So here is a unit rate. Now this is a different store. These are not going to be equal. So store B, or they may not be equal. I don't know until I do some math. Okay, let's go ahead on the graph. Before I even read the question, let's go ahead and calculate what we can. And where did it go? There it is. So slope, according to rise over run, is rise 3, run 2, rise 3, run 2. So slope is 3 over 2. Or 1.5. The constant of proportionality is 1.5. And the unit rate is 3 over 2. Okay, the table and the graph show the cost in dollars Y. So this is dollars. That means this is dollars. Of X pounds of apples. So this is dollars, this is pounds. At 2 local grocery stores. At which store does it cost less to buy 5 pounds of apples? Well, if the unit rate is 3 to 2, that means that a single pound would be $1.50. A single pound at store A is $1.50. A single pound at store B is $1.70. So I can already tell you that store A costs less. I can even tell you that it's 20 cents less per pound. That's the answer to the first question. The second thing says to describe a way you could answer this question without calculating the cost of 5 pounds of apples at either store. Well, we just did it. If we find the unit rate for each store, we know which store is cheaper because both denominators R1. So find the unit rate for each store. And then compare the unit rates. Okay, that brings us to the bottom of page 157 and to the end of lesson 5.1. So I'll see you in the next video, and we will start lesson 5.2.